Okay, so in this video we're going to talk about using law of sines to solve for all the dimensions of a triangle. So we know law of sines is basically telling us that for all triangles, the ratio of the sine of an angle to the opposite side is equal for all three angles in their corresponding opposite sides. And what we can say is, if we're given three dimensions that include one ratio, right, one angle and its corresponding opposite side, then we can use that ratio to solve for all of the dimensions that we're missing in a triangle. And we can do this in three scenarios: when we have angle, angle, side, angle, or side, side, angle. Now right here, angle, angle, side, and angle, side, angle are both congruence relationships for triangles. So basically what that means is they're going to define one triangle, right? And what that means that we're going to be always solving for the dimensions of one triangle. Side, side, angle is not a congruence relationship, and this means that we're not always going to get just one triangle. It could be that we have one triangle with side, side, angle. It could be that the dimensions will give us two different triangles, or it could be that the dimensions give us no triangles. And we're going to investigate that in a little bit. So what we want to do right now is just go ahead and for all the dimensions that we're missing in our triangle, give an angle, angle, side, and angle, side, angle. So right here, let's start with angle, angle, side. So right here, we're given angle A is 36 degrees, angle B is 48 degrees, and side A as length 8 for some triangle. So right here, let's draw that triangle. We draw that triangle, looks like this. Right here, we've got our angle A, right? We've got our angle B, and we've got our side A opposite our angle A. That means that the dimensions we're missing are side B, angle C, and side little c. So right here what we're going to do is set up the ratio that we have, which is the ratio for A, right? Angle A to side A. So we've got sine of 36 degrees, that's angle A, to our length of 8, which is the side opposite A. And right here, we're going to set that equal to the ratio involving the other dimension that we're given, right? So the other dimension we're given is angle B, so we're going to say sine of angle B, 48 degrees, over, and then side B, which is one of the dimensions we're missing. Now right here, what we've got is an equation involving the variable side little b. And right here, what we can do to solve for B is basically just multiply B on both sides. And now right here, what we can also do is, after we multiply by B on both sides, we can multiply by the reciprocal of sine of 36 over 8. And when we do that, what we're given is B is equal to, right here, 8 sine of 48 degrees over sine of 36 degrees. And right here, that gives us side B as 10.11. So we've got side B as a length 10.11 of some unit. We're not specifying the unit here. Now right here we don't have angle C or side C, but we do know that there are 180 degrees in a triangle, right? So we can say that angle C must be 180 degrees minus the sum of the other two angles, 36 degrees and 48 degrees. And that's going to give us our angle C as 96 degrees. And now since we've got angle C, we can use our original ratio in the same way we did with angle B to solve for side little c. So right here we can say now that sine of 36 degrees over our side of 8 equals sine of 96 degrees over side little c. And then right here, we multiply c on both sides and then multiply by the reciprocal of sine of 36 over 8. And that gives us c as equal to 8 sine of 96 degrees over sine of 36 degrees. And that gives us our side little c as 13.53. And those are all the dimensions. So right here, what we want to try to do is get one ratio and use that ratio through the whole problem. Now we want to use this ratio through the whole problem because it's got the most accurate numbers in it. So right here it's going to give us the most accurate outputs for all the dimensions we're solving for. So right here with angle side angle, if we look, we can say that the dimensions we're given aren't actually giving us a ratio. But we do have two of our three angles, right? So we can solve for our angle C by saying we know that angle C is going to basically be 180 degrees minus the sum of the other two angles, 25 degrees plus 41 degrees. Now right here, that'll give us angle C, which we'll be able to use in a ratio with side C to solve for the other two sides that we're missing, side A and side B. So why don't you guys go ahead and give that a shot, and we'll come back and look at this in a second. Go ahead and pause the video and give this a shot. Okay, so we can solve for our angle C right off the bat by saying that we know that angle C has got to be equal to 180 degrees minus the sum of the other two angles. That gives us angle C as 116 degrees. Now we've got our angle C and our side C, and we can use those in a ratio to solve for side A and side B, the other two dimensions we're missing. Right here we've got sine of 116 degrees over 8 equals sine of 25 degrees over A, multiplied by A on both sides, then multiplied by the reciprocal of sine of 116 degrees over 8, and that gives us A as 8 times sine of 25 over sine of 116, which gives us our side 8 as being of length 3.76. Then right here we can do the same thing with B. We'll multiply B on both sides, then multiply by, again, the reciprocal of sine of 116 over 8. And right here, that gives us side B as being of length 5.84.